Good morning. It's really exciting to be here. I'm Albert Greenberg. I lead the Azure networking team. I'm the CVP for Azure Networking in development, the development team. I'm going to be talking about the work of the Azure networking team. Think of Azure networking as what adds scale to the cloud, and if you want to have a analogy to the body, think of it as the muscle of the cloud. We have several exciting announcements here at Ignite, and you've heard about it in the morning session from Yusuf. What I'm going to talk about is what is at the essence of it, what is behind it, what is zone redundant gateways for VPN and ExpressRoute mean? How do we build it? What is ExpressRoute Global Reach? What is Virtual WAN? And I will go under the hood and explain how that works. Now, it's built on top of multiple components, multiple parts, if you will. And I think what you'll see is that the value of the whole is much greater than the value of the sum of the individual parts. And we can do much more with this platform. It is a platform, and we want your feedback. That's why it makes sense to expose it here. So to get your feedback, and we're here to take every question. Now, what you'll see innovation and invention, industry-leading invention in hardware and in software. And you'll see that this gives us 10x improvements and basically industry-leading performance. Moreover, the development philosophy is open. So you'll be able to obtain these components if it's hardware, as open specs in most cases, or if it's software, you can download it from GitHub. Now, at the bottom of it, what you'll see repeated throughout my talk is an obsession with reliability. And you'll see how we have redundant components and monitoring and built into the very fabric of everything we do in network reliability. This should come through throughout the talk. Here is the wide set of announcements that we made just this morning. Now, what I'll do is focus on the first two categories. We break up the features into connect, protect, deliver, and monitor. And I will focus on connect and deliver. There's much more, which you can get in the other sessions. Now, what you'll see is that in this focus on connect and deliver, that again, this reliability focus, you'll see awareness of availability zones, and that will be built in, and we'll tell you how we build in availability zones. And you'll see something new and really exciting for us, which is Virtual WAN. So the idea is we built this WAN, and we're supporting all of Microsoft and all of Azure, all of Office on it. And we allow these parties to optimally route and stand up in the cloud. Now the WAN is in your hands. You can use it. You can define your own policies, interconnect branch offices directly or into Azure or storage or virtual networks, and do it at 100 gigs. So again, 10x faster than the industry. And I'll show it to you. We'll demo it on stage. When we get to delivery, we'll talk about the new announcement of Azure Front Door. That is the way you'll be able to globally accelerate your applications, a new way that we're offering based on hundreds of edge sites deployed around the globe and our software. So how do we think of our mission? Well, there are two parts to it, and this is you should sort of feel this come throughout the talk. We create a super large, super reliable, super secure network. And we do this for Azure, we do this for O365. And what's new, what we're offering here is we're opening it up to you. You're in the driver's seat, you can use this network in new ways. So here's what we call the left to right view, the entire span of Azure networking. And if you start at the left-hand side, we'll talk about innovation in hardware. The industry has not necessarily produced the hardware that we need and we have the right people on staff that can design the right hardware for the cloud, the cost optimized, the cloud native hardware. And I'll show that again, that this innovation is focused on reliability at every component. And so we had to reinvent our hardware and our own firmware and our own optics, and I'll talk about that. I'll even start at the last inch, where we have reinvented the NIC, the network interface card, and talk about our latest smart NIC. I'll show it to you, which integrates ASICs and FPGAs. We created our own data center networks and our own regional networks, our own WAN. This is all dedicated to Microsoft. And a plethora of service and virtual networks on top. From VNETs, virtual networks, to bare metal, for example, SAP on Azure, HSM on Azure, and what you'll see in some of the sessions here. Of course, as you go to the right, we meet the ISPs and the internet through public and private peering. And we've now extended out to the CDN, adding our own Azure Front Door, spanning the last mile to the prem. So let's focus on connectivity. So you've heard about availability zones at the previous Ignite, and at the bottom you see 3 zones in a region. So think of a region as 1.5 milliseconds or so in span, and that's a fantastic number because it allows you to in region replicate the data and get super high availability. And these availability zones are sufficiently separated that you're protected from zone failure. So we have been talking about availability zones, and we've implemented for our own components, for storage, for compute, for SQL, for networking, zone redundancy. And in this picture that you'll see on the right-hand side, I've got reserved public IP, which is available to you. You can carve out IP ranges and reserve them. And goes into our new load balancer, the Azure Standard Load Balancer, and then crosses region. And now in the blue dotted box are the cross-zone gateways. So we can scale and place these gateways in different zones, ExpressRoute and VPN, so that you're redundant, you're resilient to zone failures. So the underlying technology is the same technology you can use as a consumer of Azure. It's virtual machine scale sets. So we use that and we extend it to our application. Now, how do we achieve these regional networks, and how do we interconnect our zones one to the other? And I can tell you that moving to a network that has super high bandwidth between zones and is resilient to zone failures was the biggest migration, we believe, in any networking history. So we didn't originally have the interconnects between the zones. We put it in without anyone noticing. Okay, so we did this massive migration of workload. We essentially changed the wings and the engine and the cockpit and everything of the plane while I was flying, and no one noticed. And I want to talk a little bit about that. Now, what you see on the left is a mock-up of what it looks like. So in order to connect the zones together in a scalable way, we implement a regional network based on what we call here regional network gateways. And these are in two different sites, and there's plenty more redundancy than 2. There's four-way redundancy everywhere. Now, that layer that interconnects the zones in the region at an amazing amount of bandwidth then interconnects up to the rest of the wide area network and the WAN. So underneath zone availability zones, all this zone awareness is this network. Now, I wanted to give you a feel for what it actually means to build one of these things. So I show here a small snapshot of the actual physical network. These are different tiers of one of the regional networks. And you can see there are lots of, there's lots of bandwidth. This is called the CLOS network. Essentially, every tier, say on the bottom of the left edge of that slide, interconnects to the next tier and interconnects to the next tier to give you tremendous bandwidth. And what's interesting and new is we used a new technology, which I'll show you, in wavelength division multiplexing, colored optics. So these are fibers, this is glass, but inside the glass there's 40 or 80 different wavelengths. And so not every one of those wires has to be its own piece of glass. This has not been done before, to my knowledge, and we innovated across the industry to do this in the metro at a reasonable cost. And let me tell you what it means. So when I hold up this part here, this is the Madison optics that we came up with, and it's industry leading. This part was not available in the industry. In a minute, I'll hold up the part that was available, just to show it to you. Now, this is a metro meaning, you know, let's say from Orlando to Daytona Beach. You know, 40 kilometers or so, you know, not too far, not Orlando to Chicago. So this is metro optimized optics that we had to buy in tens of thousands, and it didn't exist. Now, one thing that I'm really proud about, and what you can think of is this container. This container is just standard metal wrapping around the guts inside. It's called a QSFP28. Inside the guts, the real thing is 1 millimeter squared and has a DSP, digital signal processor, on it with over 1 billion gates, okay? So that's the innovation that makes it go. But what's really interesting is that this is the same container you plug in everywhere, okay? So this is nothing special. This data center staff know what to do with it. It is the equivalent of a shipping container. If you think about, you know, moving goods across the world, this one container allows us to have a standard, simple process for running the cloud. Moreover, it has this amazing digital signal processing inside, and we need to upgrade the firmware. We can do it with standard methods, nothing exotic here. So this was an industry-changing tech that we implemented for the regional network. And again, we're obsessed with quality. The diagrams on the right have to do with the monitoring and showing that we're getting good light, clean signal end to end. Now, just to, this is what this nice piece of gear is what the industry instead provides before we came with Madison Optics. This thing is a little bit heavy. It has exotic materials in it, lithium niobate, iridium phosphide, various interesting things. And I want to show you what it means to innovate. So we took tons of those out of the network. Tons of those things disappeared in something as smaller than the little joint on my finger. And that gives us the reliability, the cost benefits, and the amazing bandwidth that we now have with the Madison Optics. So this is all underneath what it takes to build regional networks and what it takes to support zones. We've done this for 100 gig, and it's going to move up to 400 gig. And I just saw this morning an announcement on LinkedIn from one of our partners, Arista, that they mentioned this joint work with us to plug it in. So you see, we've simplified. It's one of the ways we improve reliability is we take boxes away. We're left with a cloud-optimized, simple network. So that little thing is pretty amazing. Now, I want to zoom in just for a second, a little deeper, to show you what's even inside the switches that we deploy. So we're obsessed with three things: velocity, serviceability, and reliability. So we have to be able to deploy new features on these switches at a great speed. We have to be able to take care of any issue and service them without any customer impact, and they have to be ultra reliable. And we were not getting that from the industry. We were not getting this combination of the three. somehow switches were thought of as different things than just servers, but actually they're pretty much the same. If you crack one open, you'll see familiar parts in it. It's running Linux, and why not just treat it as a server? Why not manage this device as a server? And that's what we do. So we use the latest in containerized networking tech to implement our own firmware and we did that because we needed the control, but more importantly, we needed the reliability. So this project is called Sonic. There's a GitHub link there. So this is, again, open for anyone to use. So that's what's inside the switches. That's what gives us the ultra reliability, gives us the velocity, serviceability. And again, it's open. It's on GitHub. So that it's based on Linux. That's what the penguin shows. Just to give you an idea of, again, we really care about ecosystem. We really care about partnering. So these are some of the Sonic partners. Now I want to zoom out and talk about the virtual WAN. We talked about virtual networks and regional networks. Let's talk about wide area networks, WAN. And you can see on the right bottom, there's what looks like a building with an antenna. That's a branch office. And you can use ExpressRoute to connect your branch offices directly over the cloud or into storage or into virtual networks. And then moving over to the left bottom, you see we have IPsec VPN connectivity into the WAN. And we have the controller of the network on top, the SD-WAN, so you can work with our partners. We talked about that this morning. So you can get a very simple, easily configurable experience from the software-defined WAN into Azure. And then we offer outbound firewall protection into the internet and internet connectivity. So you can come to us, use our WAN. Okay. So these are some of the partners for the software-defined WAN. Really excited about that. It was great to see VeloCloud up there this morning. Let's try this. Okay. These are the partners that help us with ExpressRoute and Direct Connect, over 200 plus partners. And now this is what the physical WAN looks like. We've announced 54 regions. We have more than 100,000 miles of fiber. I guess we can span the equator 4 times with the fiber we've got. We've got 130 plus edge sites. I'll talk a little bit about those. Those are the red dots here. And again, the 200 plus partners. So this is a depiction of our physical WAN. I would love to show you the real graph. It is the most complex, interesting graph you've ever seen. This is an artist's depiction. But we know every single plug, every single wire, every single switch in this graph, and we manage it all through software. Okay. Now, one way that we do this, and do this with great performance, is we collect data on latency and throughput from around the internet. We have an amazing system that produces these latency and throughput metrics, round trip time from anywhere in the internet to us. And we are able to build an entire map of the internet. And so from this map, we can constantly optimize and adapt as things change and make sure that our WAN is doing the right thing and our edge sites are in the right place and our peers are with the right partners. So this measurement and algorithmic-driven approach to networking is at the heart of what we do. So this is a very small part of the picture that we get from trace routes and pings and other techniques across the entire internet. Now let me tell you a little bit about this. We're offering you this virtual WAN. What do we do to make it super high capacity, always available, working always for you? So up on the left-hand side, we have a picture of the network. And the green lines in the slide indicate congestion. Okay, or the incipient congestion that could happen if we don't augment those links. So the question when you're running a WAN is, well, what do I do about that? Do I now augment those links? They were 100 gig. Do I make them 400 gig? What should I do? But really, you don't have to, think of it link by link. It's a network. It's a graph. So you should run perhaps a new link, and that's what that dotted line shows. And that gives you the diversity, that gives you the capacity, and it's more efficient, and it balances the load better. Now, behind all that, and what's run constantly every day, is a whole set of tools. We use the cloud to build the cloud. So the data flows in. I showed you a little bit of the data. And then we run in Azure massive Monte Carlo simulations looking at every possible fault, fiber cut, ocean anchor that might hit a cable, and make sure that we're okay. Hurricanes, typhoons, what have you, we're okay. So we bring it through this pipeline, and we do a lot of interesting machine learning and optimization. And in the end, we get out a result of an action, what we should do to improve the network. And we do this all the time. It's continuous, and we take these actions every day. Now, last Ignite, my boss, Jason Zander, got up and showed a boat of us dragging a fiber across the Atlantic. It's called the Maria fiber because it goes by the Maria Islands, I suppose, from Virginia to Spain. And what we as engineers are really proud of, and what I want to assure you about, is that's a great fiber. We monitor that thing up the yazoo. It's got fantastic quality, and what you see that the spikes on the right-hand side is for each line there's an amplifier, and what's happening there is we use a technique called backscatter. So some of the light that you ping from with a dummy signal from one end or the other end backscatters to our sensors, and with a signature that tells us which amplifier. If there's an incipient problem in the ocean, we want to know about it before it becomes a problem. And so because it takes some time to get a boat out there to fix problems in the ocean. So that's why we produce this technology, and we can localize any problems to within 100 meters. This thing is 6,000 kilometers long. We can localize problems to within 100 meters. Now, I mentioned this before, the network is large and complex, and even though we make it as simple as possible, there are lots of pieces. So really it's too big to look at and say that looks like a good design, or that WAN is the right, it's beyond the comprehension of humans to do these things. And so the network's managed by machines. And we treat network engineering like we treat software engineering. So there's a continuous integration, continuous deployment pipeline. What does that mean? It means that before an engineer implements a change, for example, to build these regional networks, they'll run it through this pipeline and see if it crosses that firewall-looking thing. And if it's not, they go back and test it again. And embedded in there, again, is an open technology, what we call open network emulator. So you can try on the devices that we deploy any change and see how it works out. Now, it's exactly the same. So we are running the very image of the software that runs on that device. It's not, in this case, a simulation. It is the image itself. So it's as if you had a device, a real physical device that had some software. That software went to sleep at night and woke up in Azure in the cloud. It couldn't tell. It still thinks it's on the device, and it still responds the same way and gets the same signals. And that way, we're able to check that every change we make is valid and has the intended effect. That also you can download from GitHub. Or you will be able to. Right now, you have to reach out to us directly, but it's coming. Let Let me go back to the virtual WAN and talk to you a little bit about the software behind it. So, I referred to Sonic and switches before. These are the box that had the penguin on top. Well, now I want to talk about the route service that supports this massive virtual WAN. And really, not your grandfather's router. It's the brain of the whole operation. It manages millions of routes. And the way it does that is it's massively distributed. So think of the switch, the fundamental component of networking, as having an agent on each device around the entire network. And you speak to those agents, and those agents program the individual switches, the small component switches. Now, when you go to the internet or the virtual network, we control internet connectivity, for example, with the cloud native firewall and the virtual network. So we're able to speak our native software-defined networking language, okay? But when we go out to partners across the Microsoft boundary, then we speak the standard network protocol. So we're bilingual. We can speak our own internal language, or we can speak BGP, which is the universal language of networking. And then from that, we can resiliently make sure that the policies that we want or that you want as a virtual WAN user are implemented consistently and monitored consistently throughout the network. So again, I think it's the largest distributed switch known to man. Now, I want to look a little bit inside of how we do the VPN. Now, I'll show you another part. So this is the newest smart NIC from Microsoft. And this allows us to implement the policies at amazing speeds. It's a combination of ASIC and FPGA. So we're able to program it from the controller that I just talked about. And to get super high speed for VPN, we've had to go to a multi-core architecture and get fantastic performance per core. And that's what we did. What's interesting also as a user is we support OpenVPN and the different security protocols like V1 and like V2, so you can now use it from your phone, use it from a laptop, use it from any device that you'd like. So how's it working out? This is the 100x slide. So we started in 2012, we made some improvements in 2014, and now in 2016, and now in 2018, we're just massively faster. So we have much better throughput, much better tunnel count, and 2 orders of magnitude more client connections. So by reworking the entire thing, listening to customer feedback, you wanted more tunnels, you wanted more speed, we created the hardware and software to deliver what you asked for. Okay, let me get to the 100G ExpressRoute. So what you have on the left-hand side is what it used to look like. So we had, again, the controller, and it was talking to a physical device and then gateways in Azure, and then programming both of them together in a consistent way. Then that would go into your VNets. And the gateways in the middle had some sort of structural bottlenecks in how fast we could go. So what we're able to do is remove that. So if we took, and you have a string of beads, we took out the beads in the middle. So now we can program exactly what we need and put those policies on the physical switch and run at hardware speeds. So that's how we got 100 gig direct from the ExpressRoute router straight to your VNet, straight to storage, straight to Azure, done in hardware. Let's look at it. Parveen? This is Parveen Patel, who runs the ExpressRoute and VPN team.
Jared, could you log in? Okay, so let me tell you a little bit about the topology. So we set up a 100G ExpressRoute circuit in US West. We're using the largest virtual machine Azure offers. It can go up to 30 gigs. So we have 4 of those running inside a virtual network. And then we have 10 clients that are running on-premise, sending data to these 4 VMs in Azure. So what you see right now is that each client is getting about 1.5 Gbps. So if I go back and look in my ExpressRoute circuit details, you will see that it's hitting about 15 Gbps. So this is real-time data. You can look at your ExpressRoute circuits at any time. So what I'm going to do is flip the internal switch to make this circuit go from ExpressRoute v1 to ExpressRoute v2. This is my operator's console. And you'll see in a minute that now the clients will be able to get higher throughput. So while that happens, let me tell you a little bit about, like Albert said, the gateway is no longer in the data path. We are programming route policies and SDN rules directly on the ExpressRoute router. The gateway gets used only for control traffic. So BGP still terminates at the gateway that speaks to your routers and manages the route configuration. It works both with storage as well as compute. So you can get 100G to storage, you can get 100G to compute. You can link more than one VNets against a circuit. So if you don't consume 100G all on one VNet, you can attach multiple VNets. If you get ExpressRoute Premium, you can connect to VNets across the globe. It's not restricted to the same region where your circuit is. And what can you do with it and what that 100G means? So you can do, this is really cloud bursting on steroids. Now you can go, transfer data at 45 terabytes an hour, or 100, or 1 full petabyte in 1 day. So if you want to transfer data or you want to run compute, this is running all of that stuff on steroid. So as you can see here, now each client is going at 9.5 Gbps. I have 10 of those, so 95 plus Gbps. So let me go minimize these, and soon the metrics will start showing that as well. So that's 100G ExpressRoute. It's available, and we're really excited that what customers can do with it. And then somebody asked, okay, what can I transfer? You could transfer all of Wikipedia with all of its history, everything, in less than half an hour, and compute it in the cloud. Do whatever you want with it. You can move that data to our storage. You can move it to your HPC clusters or other machine learning or big data workloads. So that's ExpressRoute 100G. This morning it was showing this, 98.5. It shows you billion bits per second. So trust me, that's really Gbps in networking. So it will refresh. It takes about a minute for it to refresh. Okay, so yeah, great. Okay, thank you. So we can switch back to 5. Okay, thank you.
Awesome, thanks, Praveen. So, one thing that, another component of the virtual WAN and the how we achieve global scale is global VNET peering. So if you have VNets anywhere in any Azure region, and we talked about this last Ignite, and we're keep adding more features to this, I'll tell you in the next slide, you can peer your VNets. This is without bottlenecks again. There's no gateway. This is straight wire-to-wire transfer at high speed. So it's interesting in the sense that it's using, again, that SDN technology, but I'll mention that we have to federate these regions together and exchange information about which of your VNets is located on which physical servers and which VM is on each server and so forth. And that requires a new infrastructure which we built that does that mapping between physical and logical. So your traffic is just, and your policies is just restricted to your, and securely restricted just to your service. And that's implemented on Azure Service Fabric. And underneath it is a new distributed system that we innovated and produced, and it's on open source again, called Ringmaster. So think of it as a Zookeeper on steroids. Now, what's new and what they'll be talk about here is all this stuff, all the SDN works with containers, okay? So, I mean, you can't go to a Walgreens without hearing people talk about Kubernetes. It's everywhere, right? And our customers love it. It's growing at a tremendous rate. So it's part of the way we do SDN, that the software-defined network, that all this networking technology also works and will be talked about today with Kubernetes. So both with the Azure Kubernetes Service, AKS, and with the Azure Container Instance Service, ACI. Now the networking magic is in that blue box called Azure CNI, Container Networking Interface, and that's also on GitHub, and you can use it and improve it, and it's up to you to see how we can do better and give us suggestions, or just take it yourself. Now I'm going to move to the delivery part of the talk. Okay. So here's a depiction of Azure Front Door. And you want to do, think of that front door as a vast front door spread across the world. It's not one thing. It's worldwide across the entire planet. And wherever your users are that want to be accelerated, you want them to go fast, have better resilience, go through the Azure Front Door. That then goes across the WAN. And then we have custom probing and custom load balancing that can go to any one of the origins or regions where you're deployed. Whichever, again, you control the policy, whatever is available and has the most bang for the buck for your customer. And that's what the app service plan shows. So you have, networking technologies like connection pooling. So all these connections are warm. You're not going to waste time spinning up new connections. And then you can bring it, for example, to SQL and do native SQL data replication. So everything's consistent. Okay, now this is a depiction of what it looks like physically. We have these data centers across the world, multiple of them, and we have edge sites across the world. So these edge sites you can think of as satellites, smaller data centers. Sometimes they're virtualized in a data center, but other times they're satellites. And we have 130 of those around the world. And then we have the WAN, the wide area network that interconnects all this stuff. This is Microsoft's WAN, okay, that we built ourselves, the one I talked about earlier. And then from that, we have the users. Let's see, there they are. And the users are guided to the best point where you connect to the quickest way to connect to Microsoft based on the measurements that we collect from the active probing. So just to give you a little bit more detail on how this works. So there on the left, you see the users. And one of the techniques that we use and make this go fast is anycast routing. What this means is the internet will find and reconverge at the moment something changes to find the best place to terminate or to guide into the WAN and into the edge. So, and if there's a condition, that's what the red down arrow shows, a condition changes, then you'll go from one Azure Front Door site to another instantly, okay? So it's very adaptive, and it's, your connections are always going to the best place. Inside the guts in the software of the Azure Front Door, we have the firewall. We've talked about web application WAF firewall. And the same tech runs in here. We have proxy, and we can terminate your HTTP, HTTPS, your web applications. And then we have the load balancer component, which has the probes. This is the really interesting part. probes back to your origins and inside our data centers, and we can actively steer, based on those probes, the traffic to hit the right origin. We have redundant paths for that. So it's, again, based on this obsession with reliability, obsession with having redundancy, and making that available to you. So let me step back. So we have, in this talk, I've tried to explain to you how we, what was a little bit under the hood, how we build this massive network, how we've innovated everything, every single optics, every single wire, every single piece of routing, all the software, and we constantly do that to meet cloud scale demands. And I've talked about connectivity and delivery and our obsession with reliability. There's a lot more in each of these boxes to talk about. What we want is your feedback. We're here, I'm here, the team is here to get your feedback. You see now how we build these things. What are your ideas? What else do you want? We delivered 100 gig. What else? We want to know. Much, much greater scale, much more zone resiliency. These are the sessions coming up that will, following sessions from networking, that will dive into each one of these things. And please, I'd like to get your feedback on the talk. Thank you.